So we're ready to test this new solution with the copy constructor. The only change that I would like to make is that I don't think we need this part, because we're already using the length of the string to copy. So this actually will lead to memory corruption beyond the block that we're allocating. So I apologize for this. Let's remove it from here. So this is the original version from the handout. I think is correct. All we need to do is just copy a certain number of characters, and this will copy the zero terminating character at the end of the string very properly. So this is the proper version. All right, so let's build this new solution and run it. So this time everything runs fine, and even when we construct the second rectangle, now we're building a deep copy of it, and we can also rename it to call it second if we'd like. So let's print this just to be sure that everything looks good. So this is rectangle 2, rectangle 2, rectangle 2, and we also print the name, because we now have the function named getName. Part of our implementation, getName. Okay, and so we'll call it rectangle 2. Right? Rectangle 2, width, height, area, and this will be the name. Right, so we're now printing the name. So let's rerun it just to make sure that it looks as we expect. Okay, so we've got a copy of the normalized rectangle, and we'll call it second because we just gave it another name. And so this time everything holds together very nicely. Another issue that we need to address, and it's usually again something related to objects that manage their own dynamic memory. That's an issue with the rectangle that we're having, is that this is not the only way to create a copy. We can also say something like this. We can say that the rectangle equals rectangle 2. So here we made a deep copy of the rectangle. So the first object holds basically a set of properties, right? The data attributes. There's like 3 of them right here, and one of them is pointer to dynamic memory. So that's fine. Okay, so this is the pointer to dynamic memory with the name of the rectangle. Now we're making a copy of it, and we know that now we're doing it correctly. So we're making an exact copy of the original box with the same width and height, but the pointer to the dynamic memory now is a deep copy of the original, right? So we make this deep copy inside our constructor, copy constructor, and we're doing this. We're pointing to the new memory. So these are deep copied version of objects. However, on this line, okay, this is an assignment. This is not creating new object, so no copy constructor is invoked. Okay, so we have an issue with this as well, because if we try this statement right now, so now once again I will redraw this one more time. Rectangle 2 is allocated, and it has all of its data inside the object. Okay, so this is the box, and of course it properly holds a pointer to dynamically allocated memory, which contains this second copy of the second, right? So this copy of this string is right here. Okay, because we set the new name, and everything is fine. And then we say, let's set the rectangle, the original object, which is also already existing in memory. Okay, this object that already exists in memory with its own set of data. And this is an assignment. And the default version of assignment operation generated for C++ structures is such that, again, it takes the binary image of everything that the source object contains and copies it over to the new object. So therefore, after copying all of this data attributes, the pointer here will be set to point to the same block of memory. Again, when at the end of the day this main function stops running and begins to return, all the destructors are invoked. So of course, once again, the latest copy, the most recent copy of the rectangle will be destroyed first, and so this object will be destroyed first, and this memory will be deallocated by its destructor. And then the second object, which was allocated earlier right here, is going to be also destroyed, and its destructor will attempt to delete the same memory the second time, and this is a big no. This is memory corruption. And then this will be destroyed, but it will be causing memory corruption. So to indicate what the problem is, we need to also, just like we're handling copy by our own copy constructor, we also have to overload an assignment operator. So let's just add this new section here and say that because of our dynamic memory allocation, we also will have overloaded operators. Okay, so we can, in C++, we can specify how this operator should work for us, and it's going to look very similar to the copy constructor, except that the signature of this operator will be very similar to the copy constructor, but the name of the operation is operator equals. Okay, so this is an overloaded function that represents an overloaded assignment operator, and it's going to return back a reference to the original rectangle. It's just part of the signature, and this is the new operation that we need to specify. So basically, the idea is that this function with this interesting name, operator equals, this is just a function that we're just about to define, will control how assignment of objects supposed to work. Okay, so let's do this, and I'll just copy from the header file this new operator and add it to the list of implementation functions that we have here. An overloaded C++ operator is just the name of the operator, like this assignment, right? The sign equals with keyword operator. And of course, because this is the name of the function that we're trying to define, it needs to be specifying that this is a member function of the structure rectangle. So yes, there is a lot of syntax, but the idea is very basic. We want to be able to describe exactly what should be happening in case if one rectangle is assigned to another. So let's get rid of this semicolon right here. And this is the body of the function. And there are a number of things that we need to be able to do. First of all, the semantics of assignment in C++ are such that chain assignments are possible, in terms of that we could use, another third rectangle and keep using assignment like this. To be able to chain assignments, we have to return basically a reference to this object. And the reference to this object, this is the object for which this operator is going to be invoked. So we need to be able to return basically there is a keyword this, which is always present in all member functions of our structure, and this is implicit pointer to the location of our object. So if we dereference this pointer, we'll be returning reference to the object for which this operator was invoked. Okay, to demonstrate basically this rectangle here, right? So it's already existing object. For this object, right? For this object, so somewhere it exists in memory. And so for this object, this function is invoked. So inside this function, keyword this is an implicit pointer to the location of this object in memory for which this function was invoked. Okay, and so if we dereference this pointer, we get access to this object and initialize a reference which we return from this operator. Okay, so that it's just a technicality that the way the assignment operators should be overloaded is that in its signature the return type is reference to an object for which assignment operator was invoked. Okay, and of course assignment happens this way. Okay, so basically this pointer is pointing to the left hand side of the assignment, and this reference is pointing to the right hand side of our assignment right here. Let me just do it more in a more clean way. I am running out of space on my desk drawing these long lines. So once again, this is a pointer to the left hand side of the assignment, and this another object is a reference to the right hand side of the assignment. So this way we have a function that can handle the right hand side of the assignment and the left hand side of the assignment. Okay, so let's finish this implementation very quickly. Another thing to be aware of when defining what assignment is doing, that we need to say if this object, right, if this object, now remember that this is right here, this object, if this object equals the address, this is actually a pointer, so if this is the same as address of another rectangle, okay, so this is the same as address of another rectangle, we don't want to do anything but immediately return. So this would happen if we did something like this. If rectangle is being assigned to itself, in this case we say it's self-assignment, it's technically it's possible, but we don't want to get into any mess allocating or deallocating memory or anything. We just if this, which is the address of this object right here, right, is the same as address of this object over here, then let's do nothing and basically return immediately. And we can add a comment here. It says avoid self-assignment. Okay, we just don't want to, we could ignore this completely. And finally, just like in the copy constructor, what we're going to do is so we will simply set the width and height. I'll just quickly do it here. So this is our actual workload. So the width is going to be equal another rectangle width. We just take the width from another rectangle. The height is going to be another rectangle height. And then we're going to call set name, right? Which is going to call set name, which will deallocate the current name and copy, make a deep copy of another rectangle name, right? So let's do it this way. So we just say rectangle equals rectangle 2, and so this is a new function that we're adding to our structure. And every time you have a need for copy constructor, it's a high likelihood that you need to overload and specify exactly what should be happening when the objects are assigned to each other, like over here. So both situations have to be taken care of, unfortunately, because we have this tricky business of allocating and deallocating memory. So hopefully, if everything is right, let's do a quick build of this program. Okay, and run it, and so it runs fine. So I'm assuming our version here is okay. So this demonstrates handling of these two situations where we are giving enough attention to making copies of objects and also taking care of assignment, which both of these operations are very close. Copy constructor and overloaded assignment operator the logic is very, very similar in both of them.